1992, the University of Maryland's Engineering Department decided, for the second time in its history, to enter the National Solar Car Competition, Sunrace 93. Based upon its previous experience in Sunrace 1990, it was determined that the key to success for this year's efforts would be improved teamwork and communication. The methodology chosen was total quality management. TQM is a management style that requires project leaders to include team members in every aspect of product development. From the design stage through the final production process, the team's efforts must be concentrated on product quality. Each team member must feel fully empowered to be a part of the management process. Team members must be kept fully informed on the success or failure of the quality of the program, and program managers must stay actively involved throughout the quality effort. The team members must learn how to solve problems together and be allowed to make the changes that they suggest. Under TQM, management must show a willingness to support those changes. The focus of the production effort must be on product quality and not on cost cutting.
You have to spend the cash when you have to spend it, and you have to buy the best material, otherwise your car will not be the best. So we had two options in getting materials. We either got them donated or we bought the best material out there, and that's how we built Pride 2.
The first milestone in the critical path of this project was the manufacture of the monocoque body structure using composite materials. The solidification of a composite structure requires that the raw components be encased in plastic so that a vacuum environment is created during the curing process. Experience in this technique is important.
For the first time, Maryland, something we had no experience at, the monocoque construction, all composite construction. And we built two cars. We built the first car for Indianapolis, learned a lot of lessons, came back and built it again, and it's still not right. I mean, we still could build the car a third and fourth time on the same design and probably make it better and better. But that's that's where experience comes in. That's what experience is all about.
In the first construction of the car, we definitely had over-designed. Designing with composites is difficult to model. We were basically over-designed the first time, just kind of in fear of not making a strong enough car. We cut down the weight of the foam the second time to a lighter foam, which was not as strong, but it was rigid enough for what we needed. We also learned manufacturing techniques. We were able to refine things that we had learned to do the first time, and such as rounding the edges of the graphite, which eliminated a crease, which can cause stress concentrations. We curved much of the areas of the body, and we reduced it in size, basically. And we made a very reliable, lighter composite body.
This was followed by rigorous stress testing and analysis.
Crispy, bad, crunchy, good.
In keeping with the spirit of TQM, management and team members jointly celebrated their success.
There we go! All right!
As time became a critical element in this project, the limited labor resources available to the team required each member to become familiar with various aspects of the manufacturing process.
Say, what is the Navy saying? It's not just a job, it's an adventure. Well, a solar car should be. It's not just a project, it's your damn life. Because if you didn't put your whole life and soul into this project, you obviously didn't put enough into it. I know I lost a lot of sleepless nights, and I know everybody else did, at least the ones that were dedicated to the project. Didn't see many friends for quite a while. Didn't see many teachers for quite a while. And you could be in the lab, you'd be working for like 4 hours, and then all of a sudden someone would crawl out from underneath the table and you had no idea they were there the whole time.
As manufacturing and construction progressed, contingency planning became an increasing concern. Simple solutions were needed for complex problems.
We have a philosophy at Maryland with solar cars. In building a solar car and designing a solar car and in trying to run a solar car. It's called KISS engineering. Keep it simple, stupid engineering. Because when you keep it simple, then when things go wrong, they're easier to fix, it's easier to understand, more people know about it. When you get really, really complex and things are intricate and all this kind of stuff, then you have a really small amount of people understanding it, and when things go wrong, maybe they're not as easy to fix. So KISS engineering, I think, worked for us, and I think it's a a kind of engineering that Maryland will keep on using because it's a winning engineering. Keeping something simple is sometimes a hard thing to do because you really want to get into your design, and trying to keep it simple can be a hard thing to do. So we definitely try to do that at Maryland, and I think we did it with this car. I think it was a simple design, but a winning design.
One of the early designs that we looked at when we were trying to determine whether we were going to run a flat array is why not run a flat array and have it rotate so that it can track the sun during the course of the day as the sun comes up in the east and sets in the west. You can have the array point to the east in the early morning and point to the west in the late afternoon. And on paper that looks pretty good because you do pick up some efficiency. But when you get ready to build the thing, you find out that it's going to be a handful on the road and it's going to get blown all over the road. In fact, any kind of side winds at all means that you would have to run the array flat. So why don't you just build it flat and keep it horizontal to begin with and not have the extra complexity of trying to have an array that tracks the sun.
Though construction continued at a fevered pace, the prototype vehicle had not been successfully operated when it was time to submit it for evaluation by the Sunrace officials.
We showed up there without a car that had ever driven anywhere, and without a car that even could drive anywhere. We had a problem with our steering. We knew that the steering was kind of weak because we'd had a little bit of a problem with it back at Maryland. Once we were at Indianapolis, we had to go through what's called the drivability test, which means you just have to go 20 meters or so and then stop. We went through that. We did that. That was fine. Then right after that, you're supposed to pull up and get your picture taken, and during that pull up to get our picture taken, the steering broke. What basically happened is one of the set screws that attaches the steering to the cable had just ripped out of its holding, and we had really no way to fix it right there. So we went through the rest of the scrutineering, and we couldn't make the U-turn, but that wasn't a seriously detrimental thing. All the way up until the end, where we went through mechanical scrutineering. We went through all of scrutineering, really, and we got nothing worse than a yellow. And then it was time for the drivability test, but we had to fix our steering before we could go out and do the drivability test, which consisted of a slalom course and a braking test. We had it fixed by about 8 o'clock that night. We just welded on. Instead of using the set screw, we used weld, and we held it with weld. And we were out driving around the next day, but we were just doing a slalom course and a braking test, and we went through all of the drivability test in the parking lot at Indy.
Though flawed and somewhat disabled, the Pride of Maryland 2 managed to limp its way through qualifications at Indianapolis. Returning to Maryland without a starting position, the team's pride had been wounded, but its resolve to build a winning vehicle had been tempered by the experience. With the knowledge that they had gained of the curved A-arm's lack of structural integrity, they redesigned a straight A-arm for their suspension system that was far more proficient. They had also observed at Indianapolis that the original body design was unnecessarily heavy. Therefore, following one of the central maxims of total quality management, the team had decided to forsake cost and strive for greater quality in their product.
When we returned from Indy, we used the improved manufacturing skills that we developed while building our first vehicle. We redesigned, we refabricated, and retooled an entirely new solar car. Some of the improvements we made were a lighter weight roll bar and dual-purpose aerodynamic fairings that could support the vehicle in an emergency situation, which it actually did when the rear suspension fell out during the race. We also had a more rigid suspension system, remanufactured the rack and pinion steering, and a much lighter chassis with fewer stress concentration points. When we were done with all the improvements and innovations, we had one truly elegant vehicle that was ready to race.
It was now time to pack and be off to Dallas, Texas.
Tony
he was making a list and checking it twice. The rest of the team was packing tires and trying to look nice. Dallas, Texas, here we come.
Anchors away, my girl! Anchors away!
The team had clearly become a cohesive unit that had learned to reduce its stress levels with its youthful exuberance and enthusiasm. They were anxious and ready to go to Dallas, Texas and begin the race.
So we didn't take the car around Indy, and thus for the race, for our starting position for the first day of the race, we didn't have one. So there were a lot of schools that did this, that didn't go around Indy. So basically what happened is the organizers on the first day of the race, they put all the schools' names who didn't go around the track in a hat basically and drew by ladder rate what your starting position was. And we drew last.